This is the given question and the first step, normalizing of impedance. This is the unity gain circle. You can highlight it if you want. We plot the normalized load impedance ZL is equal to 2 plus J2 on the Smith chart. We also draw the VSWR circle. We obtain the admittance by extending the normalized load impedance to cut the VSWR circle at its diametrically opposite point. The value of admittance that we get is YL is equal to 0.25 plus J 0.25, and its value in terms of lambda is 0.458 lambda. We draw a line joining the center of the Smith chart and the point corresponding to 0.358 lambda to cut the VSWR circle at YD1. We obtain YD1 as 0.55 minus J 1.08. Since the value of beta d obtained is 270 degree, we draw the spacing circle in the lower half of the Smith chart by taking its radius equal to half the length of the line joining the center of the Smith chart and the minus J1 point on the Smith chart. If we would have obtained 2 beta d to be 90 degree, we would have drawn the spacing circle in the upper half of the Smith chart by taking its radius equal to half the length of the line joining the center of the Smith chart and the plus J1 point on the Smith chart. The real part of YD1 is 0.55. So rotate YD1 along its real part in the clockwise direction and in the anti-clockwise direction to obtain 2 points of intersection of the real part of YD1 with the spacing circle. The 2 points are named Y11 and Y11 dash. The value of Y11 is 0.55 minus J 0.11 and the value of Y11 dash is 0.55 minus J 1.88. Now we plot YS1 and YS1 dash on the Smith chart and obtain their values in terms of lambda. The value of YS1 in terms of lambda is 0.123 lambda and the value of YS1 dash in terms of lambda is 0.393 lambda. Since the value of YS1 is less than 0.25 lambda, we add 0.25 lambda to it to get the value of L1, which is 0.373 lambda. Similarly, since the value of ys1 dash is greater than 0.25 lambda, we subtract 0.25 lambda from it to get the value of L1 dash, which is 0.143 lambda. Now we draw the VSWR circles of y11 and y11 dash. For obtaining the point of intersection of the VSWR circle of y11 and the unity gain circle, we move in the clockwise direction to get an angle of rotation somewhat 270 degree. So we take the second point of intersection and name it as yd2, and its value is 1 minus j 0.61. We repeat the same process for y11 dash and move in the clockwise direction to get an angle of rotation somewhat 270 degree, and in this case we take the first point of intersection and name it as yd2 dash, and its value is 1 plus j 2.6. Now we take the imaginary part of yd2, which is minus j 0.61, and take its conjugate, which is plus j 0.61, and plot it on the Smith chart and obtain its value in terms of lambda, which is 0.087 lambda. Similarly, for yd2 dash, the imaginary value is plus j 2.6. We take its conjugate, that is minus j 2.6, and plot it on the Smith chart and obtain its value in terms of lambda, which is 0.308 lambda. Since 0.087 lambda is less than 0.25 lambda, we add 0.25 lambda to it to obtain the value of L2, which is 0.337 lambda. Similarly, since 0.308 lambda is greater than 0.25 lambda, we subtract 0.25 lambda from it to obtain the value of L2 dash, which is 0.058 lambda. Hence, the final solution consists of L1, L1 dash, L2 and L2 dash.